Let's talk a little bit about microphones. Microphones convert acoustic energy into an electrical signal. The topic of microphones is complex, but for this course we're going to focus in on a few basic types of microphones. The two most common types of microphones are dynamic and condenser. Dynamic microphones are highly dependable, rugged, and reliable. Dynamic microphones are fairly simple in construction. In fact, they work much the same way a loudspeaker does, only in reverse. There is a diaphragm that is attached to a small coil of wire. The coil is positioned in the field of a permanent magnet. When the sound waves move the diaphragm, it also moves the coil and produces a small electrical current. And this is the signal of the microphone. It is because of this construction that they are common on stages where ruggedness is important. Although dynamic microphones are not super accurate, modern dynamic microphones sound fantastic and are widely used in recording and live productions. Condenser microphones are different from dynamic microphones for a few reasons. The diaphragm element, which is the component that moves when it gets excited with sound, is much lighter compared to a dynamic microphone. Because the element is lighter, it can respond much faster to vibrations and is much more accurate than a dynamic microphone. Condenser microphones also contain electronics to make them function. Because of the more delicate construction and electronics, condensers are not quite as rugged or durable as dynamic microphones. To make these electronics function, all condenser microphones need power. Some condensers use a battery, but more often they use something called phantom power. No, not that phantom. Phantom power, in the context of professional audio equipment, is a method of transmitting power through microphone cables to operate the active electronic circuitry. All microphones have a polar pattern that indicates how sensitive the microphone is to the sound coming from different directions. You can think about this like a flashlight in a dark room. Wherever the light is emitting is where the microphone is most sensitive to sound. An omnidirectional pattern responds to sounds in nearly all directions. A cardioid pattern looks like a fat heart and rejects sound from directly behind the microphone element. Supercardioid and hypercardioid have slightly narrower patterns in the front, but start to accept sounds coming from the rear of the microphone. These microphones reject sound from a rear angle. A shotgun microphone has a pattern that is very narrow in front and has a narrow response from the rear, but does a good job of rejecting sounds from the sides. Let's take a look at some different microphones and see how they respond to sound coming from different directions.